Dear students, yesterday we have completed about good morning first. Good morning to all of you, my dear students. Yesterday we have completed about in the testing chapter standard test methods, performance standards, atmospheric conditions for testing, and fiber identification. So today we will see what we will do today, how many topics we can cover today. So we 5.4 is fiber identification, 5.5 is fabric weight and construction. So you know what do you mean by fabric weight? So it's very simple thing, GSM, grams per square meter. Practically all fabric is bought and sold on the basis of weight and type of construction. Therefore, it is very important to measure fabric weight, verify its construction in terms of type of weave and ends and picks per centimeter, or type of knits, veils and courses, knit type of knit, veils and courses per centimeter. The number of ends, picks or veils and courses per centimeter is also known as thread count or fabric count. Fabric weight is normally expressed in grams per square meter. The number of ends, picks or veils and courses per centimeter is also known as thread count or fabric count. Fabric weight is normally expressed in grams per square meter. One method to measure the fabric weight is to cut 1 meter fabric from a roll, condition it for at least 4 hours, and then weigh it and calculate fabric weight in terms of grams per square meter. Fabric weight is equal to fabric weight in grams divided by length of fabric in meters into width of fabric in meters. If 1 meter fabric is not available for testing, small piece of fabric can be weighed. However, the test specimen should not be smaller than 5 cm into 5 cm. If sufficient fabric is available, then the desired specimen size is 50 cm into 50 cm. It is customary to take at least 3 to 5 specimens. It is customary to take at least 3 to 5 specimens to weigh, and the final test result is expressed as an average of the test results of these specimens in terms of grams per square meter. Fabric construction can be checked by examining fabric sample under pick glass. So how do you analyze fabric construction? So fabric construction can be checked by examining fabric sample under pick glass, which is a magnifying glass with the power of 10x. That means 10 times magnification. Fabric construction is checked on one specimen only. However, the thread count is performed on at least 3 to 5 specimens, and the final test result is expressed as an average of the test results of the specimens in terms of number of ends or veils and picks per or courses per centimeter. So, however, the thread count is performed on at least 3 to 5 specimens, and the final test results is expressed as an average of the test results of the specimens in terms of number of ends and or weights and picks or courses per centimeter. Following ASTM methods, test methods cover procedures for determining fabric weight and construction respectively. D3775 warp and count and filling pick count of woven fabric, annual book of ASTM standards, volume 0.707.01. D3776 mass per unit area of fabric, annual book of ASTM standards. D3887 standard specification for tolerances of knitted fabrics, annual book of ASTM standards. So dear students, fabric weight and construction is very important. Fabric weight generally means grams per square meter. The minimum sample size is 5 centimeter into 5 centimeter. Otherwise, we can take a sample of 50 centimeter length into 50 centimeter width. So fabric weight is equal to, that is gram in grams per square meter is equal to, so we have to weigh the fabric of 50 centimeter into 50 centimeter on a balance, and that is the numerator, and divided by 50 into 50 because length of fabric is 50 centimeters and width of fabric is 50 centimeters. So we have to convert it into square meters, and then we have to find out fabric weight. So that is the thing that we have to get. So the number of ends, picks is known as thread count. So thread count is also very important. Thread count is also very important. So how do you measure thread count? So thread count is also known as ends per inch, picks per inch. So this can be found out by pick glass or counting glass. So pick glass is a small device used, which is a magnifying glass where you can find the magnify the fabric and measure the number of ends per inch or picks per inch. Number of ends per inch or picks per inch. So 5 specimens are taken and tested for ends per inch. That means 5 readings of ends per inch of the same fabric are taken and the average is taken, and that is ends per inch of that fabric. Similarly, 5 samples are taken and 5 picks per centimeter or 5 picks per inch are taken of the 5 samples, and the average of those 5 results are taken, and this is the picks per inch of the fabric. We can take 5 samples or 10 samples. So maximum is 10, so minimum is 5. So this is the way to find out the thread count, the R ends per inch, picks per inch, and this is known as fabric construction. So there are ASTM standard methods for count, end count, and peak count, that is that are available in the annual book of ASTM standards D3775, D3776. D3776 is about mass per unit area of fabric, that means weight of the fabric, and D3887 is about knitted fabrics testing. So, dear students, now we have completed fabric weight and construction. So, it is getting tough. Taking 40 minutes classes is not that easy. Oh God. You all people will come to know in your, that too without students in front of me, that too like a person like me who likes students and interaction with students. So this is a non-interactive session, so going on reading and telling to walls and chairs is not a an enjoyable job generally, but still I enjoy like even like these classes also. So now I will show you what is a counting classes, because we have some time. All of you know about pick glass, but I will just show for 1 second. Doesn't matter. So dear students, this is a pick glass. With the pick glass we can find out ends per inch or picks per inch. So next, strength properties of apparel. Now we are into strength properties. The strength properties of apparel have traditionally been considered the most obvious indicator of the service life of apparel. Excuse me.